These two rules are, the first one is that the angles subtended in opposite segments add up to 180 degrees. That's also known as opposite angles in a cyclic quadrilateral add up to 180 degrees. Here you ask, what is a cyclic quadrilateral? It is a quadrilateral where all four vertices, all four corners of the quadrilateral touch the edge of the circle. So that's the first rule. Second one is that the angle between a tangent and a chord is equal to the subtended in the opposite segment. That might look a little bit confusing, but in essence it's telling us that we've got a chord and we've got a triangle within there, that these two red angles are the same, and equally this blue one, again between the tangent and the chord, we've got the same angle on the opposite side. So how are those in practice? Find the angles x and y. For the first one, x, so we can put in the calculation we want to do. We're going to say 116 plus x is equal to 180, because we've got a cyclic quadrilateral, all four sides touch the edge of the circle. Which is going to tell us that x is equal to 64 degrees, because, and then we put in the rule, opposite angles in a cyclic quadrilateral. Sum to 180 degrees. Okay, so there's the first one. Second one, let's do some different colour. We've got to take a couple more steps. We can't do that immediately because this isn't a cyclic quadrilateral. This point doesn't touch the edge of the circle. But what we could do is make one that does. So we've got three parts here and here of a cyclic quadrilateral. So I'm going to add in an extra shape. Let's add that in there. Now I could find out this angle. I'm going to call it, well, we've used x already, so I'm going to call it z. I'm going to say 96 plus z equals 180. So z equals 84 degrees for exactly the same reason that we had before. I'm just going to copy it, but you could write it out, because opposite angles in a cyclic quadrilateral sum to 180. So how does that help us? The key thing is to look at this. I'm going to do a different colour again. If we imagine this line across here, this is a common chord. We've got one angle in the centre and one angle at the circumference coming off the same common chord. So we can then write y is equal to 84 times 2, which tells us that y is equal to 168 degrees, because angle at the centre is twice the angle at the circumference. So this is a common thing, is that you have to use another rule, or maybe add in your own lines. There may be different ways you can go about them, but this one here, you can add in your own lines and then use your own rules. And also this one with the angle at the centre being twice the angle at the circumference, or the one where the angles are the same at the circumference, those can be hidden in a way that isn't always easy to spot. So you often have to have two steps, and as we did before, you must show this working as you go.